Guys, can you hear me? Just put a yes if you're able to hear me so that I can start with this class. Sorry for the delay. There has been a small problem. Uh, Guys, can you hear me, please? Just put a chat. Just put a yes in the chat. If you, oh, great. Fine. So, most of the time I'll be reading a chat to get an understanding of what is that you're coming to speak. Sorry for the delay that has happened in this entire session of class. It was not prone to happen, but I don't know what went wrong. Luckily, I'm able to patch it up. Okay, so maybe this will give an idea if there's any problem. So from the next class onwards, maybe a YouTube live will do good. Great. So we're talking about linear programming as a whole. So this class again we're going to take it to the next level. What exactly do you mean by the word linear programming, right? So of course there are many let me say meanings to this particular word linear as a whole. Linear, if you just take it in a very simpler format, what has happened is, guys, can you hear me? Just put a yes if you're able to hear me so that I can start with this class. Sorry for the delay. There has been a small problem. Uh, right. So this particular word, linear, it means that uh, basically just take an example of a line. Okay. So a line is told to be a linear case. Fine. So if you talk about a line, the equation of the line goes like, y is equal to mx plus c. So that is the equation of a line. That equation is told to be linear. Similarly, if you tell that you have a curve, y is, for example, a parabola. Okay, so y is equal to ax square, where a is a constant. So that also can be converted into a linear equation, right? So this concept of linear, if it has to be told mathematically, the number of equations will be equal to the number of unknowns. Okay, so for instance, if you're going to have two equations, obviously you'll be having a minimum of, uh, let me say, two unknowns in it. Okay, let me just rephrase it. Number of unknowns is equal to the number of equations on a minimum level. Sometimes the number of unknowns will be lesser than that of the number of equations. Then also it is termed as a linear equation. Okay, so this concept was the first thing that has been brought in operation research as a whole. Okay, so if we talk about operation research, as we told, first it was used in the World War II, and based upon that, the first concept of operation research is basically this concept of linear programming. Got it? Fine. So we'll take a particular problem. Okay, I think we will not be able to solve this particular problem entirely, but we'll take this very small problem. Or rather than this particular problem, let me just 1 second. Let me put another problem, which might be better. Just hold on for a second. There might be some lags in this particular case. Please bear with it. Right. So first we'll start with this particular problem. Though it is a simple problem, it will give us some insight to it. And then we'll get to that particular problem which we've actually looking onto the slide. Okay. So how we are going to solve this particular problem is by using a graphical solution. And then we are going to address this concept of linear programming, right? So as it goes, we have a problem. So we have three chemicals. chemical A, chemical B, and chemical C respectively, which is required in a workshop. And the quantity is 10, 12, and 12 units. Okay, I'll repeat it. So you require 10 units of chemical A, 12 units of chemical B, and another 12 units of chemical C in a workshop. Fine. So again, the next category is the chemicals can be either in a liquid form or a dry form. Okay, so the next line is a liquid product contains 5, 2, and 1 unit of chemicals A, B, and C respectively. Okay, so we have a liquid product of chemicals where chemical A is of 5 units, chemical B is of 2 units, and chemical C is of 1 unit. Similar to this, as I told you, a dry product also do exist. So when it comes to the dry product, chemical A has 1 unit, chemical B has 2 units, and chemical 4 has basically C units in it. Okay, so they have mentioned what is the total number of chemicals that are needed in a particular workshop. Then they have categorized that into two. So they have categorized into liquid as well as a dry form, liquid product and a dry product. That also they have mentioned what is the number of units that has to be taken care of. The next line is, if a product sells of rupees 30 per bottle and a dry product is sold for 20 per bottle, how many of each should be purchased to minimize the cost and attain the requirement? Okay, so instead of reading the whole paragraph of question, what they have told is liquid product, the cost is 30, dry product, the cost is 20, right? But as given in the first line, we require 10 units of chemical A, 12 units of chemical B, and another 12 units of chemical C. So these are the minimum requirements. You have to purchase these minimum requirements of chemicals either as a dry product or as a liquid product. But what is the most important criteria is the cost should be minimized to the least as much as possible. Okay, so that is how we are going to approach this particular problem. So this can be taken up as this particular tabular column, right? So if you look into this particular tabular column, it has been mentioned very clearly that over here, as mentioned, chemicals, as I have told in the question, the minimum required. Okay, so you need 10, 12 of B, and 12 of C. Okay, so these are the minimum requirements that are required in a particular product. Okay, and then there are two options that are given to us. Fine, so this liquid can be considered as X1. Dry can be considered as a product of X2. So there are two categories under which we can perform. There again, 5 of liquid, 5 units of liquid, 2 units of chemical B, and 1 unit of chemical C. Similar in the dry also, you can just look into it. 1 unit of A, 2 unit of B, and 4 units of B. So what I've done over here is I've introduced two terms, X1 and X2. Okay, so X1 symbolizes that it falls under the category of liquid product, whereas X2, it symbolizes that it falls under the category of dry product. Okay, so what is our requirement over here is as simple as that. You have to minimize the cost, right? So if you try to recollect the procedures that are available in the first class, what we have seen is basically the first thing is you have to define a problem and then you have to collect the data. Okay, so the problem is given to us. Previous slide you have seen the problem was given to us, and similar to this here also you have found out that the data is also given. So the first two steps are over. The third step is you have to derive a mathematical equation or mathematical model or basically a small hypothetical model. Okay, so this is where this comes into picture. Fine. So you have to go for a minimal cost. Let me just put Z. So Z is the minimal cost that has to be attained with. So now I have to develop an equation. Z is equal to some number into x1 plus some number into x2. So this is the mathematical model or hypothesis that we have to develop. So we'll see how this goes on. Right. So I have written minimize Z is equal to 30x1 plus 20x2. How is that I have written 30 and 20? Very simple. Get into the problem once again. Let me go into the previous slide. So here you can see that the liquid product is rupees 30 per bottle and the dry product is 20 per bottle. So this, of course, 30 per bottle in the sense like 30 rupees per bottle and 20 in the sense like 20 rupees per bottle. So basically what we're looking on is the price. And here what you have to do is minimize the price as a whole. So here, so as I told, so this is considered as x1 and this will be considered as x2. So our main ideology is minimizing the costs. So Z over here corresponds to the cost in terms of rupees, and this 30 that is put in front of x1, go to the problem, it is rupees 30 per bottle for liquid. Okay, I'm not going to read it fully. And what is this particular 20? This 20 corresponds to rupees 20 per bottle for dry product. Okay, so this is where we have derived this particular equation. It's not a very big equation, a very simple equation that we have taken up from the formula. Why is that I'm specifically taking this particular 30 and 20? Read the question, last line. It has been mentioned, your main duty is to minimize the cost involved with the purchase of this particular equipment. So what we have done, 30 rupees per bottle and 20 rupees per bottle. So these are the costs. So that is the reason why I've taken this. Okay, got it. So now we have arrived at one of the equation. Similar to this, we are going to arrive at different equations. What is the next equation? Right. So this is a little obscure. 5x1 plus x2 is greater than 10. It should be greater than or equal to 10. How come this equation 1 is derived? Right. So look into this particular tabular column once again. First line of the question goes like, minimum you require 10 units of chemical A, minimum. Okay, so either it can be as a liquid or as a dry product, but 5 should be there as a liquid, 1 should be as the dry product. So 5 into x1 plus 1 into x2, which is just x2, should be greater than or equal to 10. Okay, that is the reason. The minimum quantity required of chemical A in a workshop is 10. Minimum in the sense, combining this 5x2, 5x1 and x2, it should be a minimum, which is equal to 10. It can also be greater, okay, which means greater than symbol also comes into picture. Again, read the equation. They have already again specified. Chemical B, the minimum requirement is 12 units. But out of the 12 units, this particular liquid should be 2 and your solid also should be 2, which means it is 2x1 plus 2x2 minimum required. So equal to will be there. Minimum requirement should be 12. It can also be greater. So you'll have a greater than symbol. So this will take the equation 2. Again, we have one more final equation. So here chemical C, of course, is the minimum requirement in the workshop 12, out of which 1 should be a liquid and 4 should be a dry product. So which means it is x1 plus 4 of x2 minimum requirement, so equal to 12. It can also be higher. So which means you're using a greater than symbol. So this is equation 3. Okay. So this is how 5x1 plus x2 greater than or equal to 10. Then we have 2x1 plus 2x2 is also greater than 12. The last one is x1 plus 4x2 is greater than 12. So this is how we have formed this equation, right? So with this, I'll stop for this particular class. If I go beyond this, obviously I'll be taking a lot of time. So with this, I'll stop for this particular class. I'll wait for your comments in the comment section. Just spend 1 minute or 2 minutes, because this is again quite new, where I'm handling it through the online mode of YouTube. Next class, I hope that particular Google Meet works fine. But let me know whether you were able to understand till this particular step. Okay, I'll wait for your comments to be put in this particular YouTube comment. Right, guys. Um, I hope you are able to understand. With this, I'll wind up for this particular class. I don't want to take much of your time because you have the next class after this. Just put some comments in that particular WhatsApp group, so that maybe I'll go through it. And if you're not able to understand, then I'll go ahead and then carry it out further. Okay. Sorry for taking up such amount of time earlier. I don't know what went wrong, but I was not able to admit some of the guys. Maybe next class I'll try to ensure that nothing goes wrong. Okay. So thank you for attending this particular session. Thank you. Bye.